we had mentioned about concepts of computer. We mentioned computer program. We also mentioned programming language, and we also gave some of the details that should involve programs. And today we are going to look at a problem algorithm. And an algorithm is a logical sequence of discrete steps that describe a complete solution to a given problem in a finite amount of time, independently of the software or hardware of the computer. It is a set of rules that define how a particular problem can be solved in finite number of ways. Algorithms are very essential as they instruct the computer what specific steps it needs to perform to carry out a particular task or solve a problem. The other thing we need to know is that every algorithm should have the following 5 characteristics. It should have an input, an output, definiteness, effectiveness, and at one point it should terminate. Then we briefly look at the efficiency of and analysis of the algorithm. How well a computer program will work depends on the quality or the nature of algorithm which was used to develop the program. And so the efficiency of an algorithm means how fast it can produce the correct results for the given problem. And the algorithm efficiency depends upon its time complexity and space complexity. And the complexity of an algorithm is a function that provides the running time and the space for data depending on the size provided by us. 2 important factors for judging the complexity of an algorithm are space complexity, which refers to the amount of memory required by the algorithm for its execution, and generation of the final output, and time complexity, which refers to the amount of computer time required by the algorithm for its execution. Then we need to get that for us to represent an algorithm, we do it in 2 ways. The steps of an algorithm can be represented using flowcharts and pseudocode. And for that reason, we are going to look at these 2 methods of representing an algorithm, starting with a flowchart. Now, a flowchart is a traditional means of showing in diagrammatic form the sequence of steps to be undertaken in solving a problem. Flowcharts or flow diagrams are important tools in writing a computer program. A flowchart allows you to plan the sequence of steps in a program before writing it. The flowchart serves as a visual representation which many programmers find indispensable in planning any program of at least moderate complexity. And we look at the elements of a flowchart. A flowchart consists of a set of boxes, the shapes of which indicate specific operations. And the separate boxes are connected with arrows to show the sequences in which the various operations are performed. We use these standard symbols. The first symbol is a rectangle, a process symbol used to represent any kind of processing activity, and details are written within the box. The second symbol is a diamond, and this is the decision symbol. It is used where a decision has to be made in selecting the subsequent path to be followed. The third symbol is an arrow, used to show the flow path of a sequence of symbols. The next symbol is a parallelogram, which is an input/output symbol, which is used where data input is to be done or data output. Then the other symbol is an oval, the terminal symbol or the start symbol, used at the first or the last part of the flowchart. So if it starts with an arrow below it, this is starting. If it has an arrow above, it shows this is a stop. Then we have a small circle, which is a connector symbol, exit, or entry from another part of the chart. Then the other method of representing an algorithm is by use of a pseudocode. And pseudocode is an alternative method of representing an algorithm to the flowcharts. Pseudocode is halfway between English and programming language, and it is based upon a few simple grammatical constructions which avoid the ambiguities of English, but which can be easily converted into computer programming languages. Pseudocode is an informal high-level description of a computer programming algorithm which omits details that are not essential for human understanding of the algorithm. Having looked at the algorithm, then we now move on to another section which we are calling program control structures. Anytime a computer is executing a task, it does it either sequentially or through selection or through repetition. And these are the three main ways. Number one, we have the sequence. In the absence of selection or repetition, program statements are executed in a sequence in which they appear in the program. So you have instruction 1, you go to instruction 2, you go to instruction 3. And this is a way you show it in form of a diagram. Then the other way is selection. This is where you involve the decision symbol and part of the decision making and allows alternative actions to be taken according to conditions that exist at a particular stage in the program execution. And this is a time when we now bring in the use of the keywords if, then, and so on. And of course, when you now use a diagram, you of course can't avoid using the decision symbol during when you are talking of selection. Then we have, of course, the keywords which are used, and we shall address them as time goes by. Then the other way is repetition. We also refer to this as iteration. At times we also talk of looping, and there are many programming problems in which the same sequence of statements need to be performed again and again for a definite or indefinite number of times. And when we are doing this, the keywords that we are going to employ is keywords like while, do, and while, or of course we shall look at a loop as the other keywords. And of course you still use the decision symbol to in fact determine how much or how many times the condition must be repeated. I think having said that, we can now stop our discussion at that point, and next time we are going to proceed to the next section of the unit develop computer program, a unit which is set to be done by the students who are being prepared for a profession of ICT technician level 5. Thank you so much.